Let's take a pause for a moment with our polynomial equations and do a bit of a recap lesson. In my experience, I found that some students are very comfortable solving inequalities and others are not. So we're going to do this sort of backtrack recap inequalities lesson so that you're prepared in order to solve polynomial inequalities in the next lesson. This is a poster I usually hang up in my classroom. Mr. Alligator is hungry for lunch. Find the biggest number and munch, munch, munch. The alligator is always eating the bigger number, or it is simply pointing to the smaller number. People usually remember inequalities in these two ways. Now, they do actually have names. The one pointing this way means less than, and pointing the other way is greater than. Just like we have a 9 is greater than 5 going on right here. And then we always add that little underline here if it is also possible that it is going to be equal to. That's when it comes from. When we solve linear inequalities, most of the time you can simply treat it as if it's an equal sign and it's going to behave the exact same way, okay? So for example, if I have a 3x minus 2 is less than or equal to negative 17, if this was an equal sign, I would move the negative 2 over. So that's what I'm going to do. It'll turn into a plus 2. Negative 17 plus 2 is 15. I can divide both sides by 3. X is less than or equal to 5. Sorry, dropped a negative there. Negative 5. That's it. We treated it as if it was an equal sign. All the math rules stayed the same. Checking your answer looks a little bit differently when it comes to inequalities. Essentially, you're going to pick a value that satisfies the inequality of the original answer, okay? So my original answer here, or I should say my answer, is x is less than or equal to negative 5. So I'm going to ask myself, what's a number that's true? Negative 10. You could pick anything. You could pick negative 200, you could pick negative 6, you could pick negative 5.5. Technically, you could even pick negative 5 because it could be equal then. Doesn't matter. What we're going to do is substitute this value, this negative 10, into my original question. And then we're going to do a left side, right side check. So here's what that looks like. You may have seen this a little bit differently with your teachers. This is how I formatted. Left side of my original question was 3x minus 2, and the right side of my original question was negative 17. I'm going to substitute in that x value now. 3 times negative 10 minus 2, negative 30 minus 2 is negative 32. We needed our left-hand side to be less than or equal to our right-hand side. Okay, so we're going to conclude here. We can say, indeed, our left-hand side is less than our right-hand side. And it's going to be written in a two-part sentence. The first part is going to say, since. If you're unfamiliar, this is like the upside down. Oh, that one's therefore. But the upside down triangle means since. So since negative 32 is less than or equal to negative 17, right side is less than or equal to left side, and then we end our proofs with this QED and a little square. It's like a blank checkbox. QED stands for something in Latin, and I can't remember it right now. Basically, it means I've proved what you wanted me to prove. Okay? So the gist with checking our answers, we pick an answer, we pick a number that should work, and then we just check to make sure that we did the math right. Okay, pretty straightforward. The only exception to this sort of rule or the concept that inequalities behave like equal signs is when we have a negative number that is being either multiplied or divided. Okay, so let me just read the sentence here. The only exception with treating an inequality like an equal sign is when you are multiplying or dividing both sides by a negative number. Okay, when that happens, you need to flip the inequality. This is simply the rules of working with inequalities. So let's do this example here. I have a negative 2x minus 3 is greater than or equal to 9, and I'm being asked to check my answer. I'm going to rewrite it over here. My first move is going to be to pull the 3 over, and it's going to turn into a positive 3. So I have a 12. And now I need to divide both sides by negative 2. And so because I'm dividing by a negative number, I now need to flip the inequality. So my inequality is going to face the other direction now. 12 is greater than, 12 divided by negative 2 is negative 6. So my answer is negative 6. Now I'm being asked to check my answer. So I'm going to use, let's use that x is, negative 8. Let's check using that. Negative 8 fulfills that condition of being less than or equal to negative 6. All right, plug it in. Left side was negative 2x minus 3. Right side was 9. Plug in that negative 8. Negative 2 times negative 8 is 16. Minus 3, which is 13. My right-hand side is 9. My initial question was asking me, is it greater than or equal to? Is 13 greater than or equal to 9? Absolutely it is. Okay. If we hadn't done that switcheroo sign, it would not have worked out. We needed to do that in order to fulfill the inequality. So I can say since 13 is greater than or equal to 9, the left-hand side is greater than or equal to the right-hand side, QED, put a little square. Now, in terms of what this looks like graphically, like when you hear the word graphically, you always think like a Cartesian grid, an XY axis. Graphically truly just means in picture format. So how does this look on a picture format? Let's start off by solving this inequality. Negative 3x, I'm going to move my 9 over. It'll become a plus 9. 24 plus 9 is 33. I divide both sides by negative 3, so I need to flip the sign. 33 divided by negative 3 is negative 11. So x is greater than or equal to negative 11. So to sketch this on a number line, to sketch this, first of all, we're just going to draw a number line. Doesn't have to be pretty. Just draw a number line. Okay. I'm going to put my number, so I'm just going to add a few tick marks. We don't need very much here. And I'm going to just write my solution in the middle over here, and I'll fill in my number line. Now, my answer is negative 11, so I'm going to circle that. Quite literally, circle the negative 11. And then there's two options here. Option number 1. I need to color my circle in if my answer could include that number, if it includes the equal to. Otherwise, I need to leave it blank if my answer does not equal that number. So in this case, I do not have an equal to sign as a part of this, and so I need to not color it in. I'm just going to leave it as an outline. Okay? And then I'm going to draw an arrow, whether it is less than or it is greater than, and my hint to you is follow this arrow. X is going to be greater than 11, which means that it could be negative 10, negative 9, negative 8. We're going to go that way. And I'm literally just drawing a line. Okay? That's it. That's all there is to it. Last concept we're going to address here, solving double inequalities. So double inequalities basically our inequality or our equations where there are two inequalities in the equation. So look at that first example here. We've got 2. We're looking, it's sort of like there's a range. You know, x is going to be in the middle of these two numbers, but we have to do a little bit of math before we can get to those two numbers. And what we are trying to do is we are trying to find a solution that is going to satisfy both inequalities, as in the one on the left and the one on the right. Sometimes this is going to be impossible, but most of the time it is going to work out. Steps to completing this, obviously we've got an inequality here in our example that has some BEDMAS in it, so we're going to simplify this. I'm going to distribute my brackets out. And then I'm going to combine my like terms. I have a 5x and a negative 2x, that'll be 3x. I've got negative 20 and positive 12, so that'll be negative 8. Okay, this is as simplified as possible. What we need to do now is we need to isolate the x term in the middle section, okay? So we're trying to get the x on its own. We need to get rid of this negative 8. Some of you are just like, well, which direction does it go? Because, you know, there is an equal sign and we always just like move it over. Not always true, actually. What you're doing when you're doing that move over is you're adding it to the other side. And in this case, there's 2 other sides. So we need to add it to both sides. I've added that 8 to both sides of my equation. Okay, let's simplify. Negative 2 plus 8 is 6. 27 plus 8 is 35. Okay? And then we're going to just divide everything by the coefficient of x. Nice and easy. Just divide that out. Okay, and we're going to simplify where we can. Obviously, 6 divided by 3, we can simplify to 2. 35 over 3, we can't. So we're going to leave it as a fraction. Now it's time to graph. We'll put our line, our number line here. And we do need some kind of a baseline, so 35 divided by 3 is 11.66, just so we have an idea. So let's do, your number line doesn't have to look good or even, just has to work. Okay. So we've got 2 different inequalities here. I'll graph, let's do this one first. X is less than 35 over 3. In this case, I am drawing a circle, but I'm not coloring it in, right? Because it is not included. And I'm going to follow my less than sign to draw my arrow this way. I also need to do my second half of my inequality. 2 is less than or equal to x. This might be confusing for you to understand and how to graph it because of just the order of things. I know people are really comfortable with an x on the left-hand side. So if you need, we can actually just swap this and we can say, well, x is greater than or equal to 2. X must be bigger than 2. Like the first sentence said 2 must be less than x, but here we've got x must be bigger than 2. So I'm going to draw a circle on the 2. This time I am going to color it in because it's also equal to. And now I'm going to draw an arrow this way. And I know my arrows have sort of ended up on diagonals, but here's what it is. Okay. Where do these overlap? That's the question. we need to find a solution that has both. And so these overlap between 2 and 35 over 3. To write about this in set builder notation, actually I'm going to do set notation. Our x value is anywhere from 2 to 35 divided by 3. It can include 2. Remember that I colored this in, and it can be equal to. So I'm going to include that square bracket. But it cannot equal to 35 over 3 because there's no equal sign there. And I left this as an empty circle. So this bracket is going to be a round bracket. Okay? All right, good recap. We've done solving inequalities. We talked about the issues with the negative sign. I've shown you how to graph them, and we've even gone so far as to do a double inequality. Great work, everybody.